In this section, we are going to discuss functional programming. You'll learn how to write code in a functional style in Kotlin. In this video, you'll learn how to define and use lambdas. Lambda is an anonymous function that can be used as expression and, for instance, passed as an argument to another function invocation. In older versions of Java, anonymous classes were used to the same purpose, but modern development languages, including Kotlin and Java 8, they all support lambdas, which provide more concise syntax for the same functionality. Having lambdas in a language also makes it possible to work with collection functional style. For instance, use such functions with filter or map, which make the overall code more readable as well. We'll discuss these functions soon. First, we'll focus on the lambda syntax. In Kotlin, lambda always goes in curly braces. And to distinguish regular curly braces, for instance, for if expression from curly braces used in lambda, ID highlights curly braces for lambdas. So when you see these highlighted curly braces, that means you see a lambda. Inside curly braces, first you specify the parameters, then an arrow, then the lambda body. If you just pass the lambda as an argument, you can put the whole lambda inside the parentheses. However, there is a better way to express that. You can you can move lambda out of parentheses if the lambda is the last argument, and if the parentheses are empty, you can even omit them. And this way you see this nice syntax. At first, the same syntactic convention were used in Groovy language, and it worked quite well there. So Kotlin just uses the same idea, which is proven to be really convenient. If the type can be inferred, if the type of the argument is clear from the context, it can be omitted. If your lambda has the only argument, you can replace its name with it. So it's automatically generated name for your lambda if it has only one argument. And if you want multi-line lambda, so you want to express some complicated logic, then you just do it, and the last expression of this lambda would be the result. Another syntactic thing that I want to highlight here, you can, if your lambda takes as an argument a pair of values, or for instance here a map entry, you can use so-called destructuring syntax, the same syntax that used to iterate over map in a for loop, by assigning key and value to separate variables. We'll discuss in the next module how exactly this destructuring syntax is used, but now how exactly it works. But the usage is that you can, instead of defining one variable entry, you can define two variables but put them in parentheses, and the compiler automatically destruct entry inside this key and value, which is quite convenient as well, because many functions take, for instance, map entry as an argument, and you can use the nice syntax to work with such functions. If one of the lambda's arguments isn't used, you can replace it with underscore, and in this case, also the syntax is more readable. You don't need to invent the name of the parameter that is not used. Sometimes it's not very easy. You've learned the syntax for lambdas. You now know that you can move a lambda out of the parentheses, use it if it's the only argument, or use destructuring declaration syntax if one of the arguments is map entry or pair. Next, we're going to discuss the common operations on collections.